So I want to thank Frank and Naresh, who couldn't be with us, and Johanna for organizing this event and for inviting me. It's a great honor to be here. This talk will bear a strong resemblance to one I gave yesterday, so I don't know how many people were there, but this one's going to be quite a lot longer, and I'll go into more detail. So apologies to those of you who were there yesterday. The primary aim in the ACTOR project, which this is part of, is to understand the conception, practice, realization, and perception of orchestration. So this talk will focus on how musical timbre depends on and affects different grouping processes, and I'll present some of the basic categories that we've developed into a full taxonomy of grouping-related orchestration devices. And along the way, I'll consider some of the challenges that arise in trying to model some of these effects, and then you can hear Aurélien Antoine's paper a little bit later about some first steps in that direction. So here are some of the possibilities of the musical deployment of timbre, but certainly not all of them, the ones particularly related to auditory grouping. First of all, you can create new timbral percepts by creating fused events by the blending of different sound sources. You can enhance the differentiation between different auditory streams or melodic lines, if you will. Here are the role of timbral similarities and differences in the formation of musical streams, and surface textures is playing a strong role. So timbre begins to take on a structuring force in music. You can form different orchestral strata or layers, so foreground and background kinds of things. And here, these are looser groupings of instruments in these foreground and background or even middle ground layers. And here the role of timbral salience can play a role in bringing sounds to the foreground in a certain sense. So what are the timbral effects that make something be in the foreground rather than in the background, and so on. And finally, we can use timbre continuity and change to create a hierarchical nesting of sections in music, from local motifs and phrases and so on, all the way up to large-scale sections. And it's the degree of change in the signals that creates the strength of various kinds of settings, parts of motifs, phrases, and sections, and so on. So the degree of change plays a strong role there. Analyses of scores and orchestration treatises reveal that many orchestration aims are implicitly related to auditory grouping principles. And in terms of auditory scene analysis, auditory grouping processes organize the acoustic environment and determine, for example, what sounds are grouped together into musical events in concurrent grouping, whether these events are connected into musical streams or layers in sequential grouping, and how listeners chunk event streams into musical units such as motifs, phrases, themes, and sections. Now, according to Al Bregman's notion that perceptual qualities are computed on the results of grouping processes, okay, what might the perceptual qualities and corresponding orchestrational effects be in these cases? So we know that timbre, pitch dynamics, and spatial position and duration even emerge from perceptual fusion of acoustical components into a single auditory event. We know that, for example, similarity in these parameters is involved in auditory stream integrations, or the perceptual connection of events over time, and differences provoke the segregation of events into different streams or different orchestral layers. And finally, discontinuities in musical parameters promote the chunking of musical units, whereas a succession of unchanging or gradually changing blended or integrated instrument sounds creates a sense of continuity, which would be chunked as a single unit. So the importance here is that auditory grouping mechanisms give rise to certain perceptual properties, such as timbre and so on, but also melodic and rhythmic properties of events, and then chunks of things that you perceive as units and hold in short-term memory. And it is these perceptual properties of these things that have been grouped together that then acquire musical functions in a musical discourse. And it's on the basis of the musical functions that arise from these things that we then want to develop a sort of psychological foundation for a theory of orchestration. Okay, so that's why auditory grouping is sort of the basis. That's the place we want to start, because it gives us information about how to actually go about doing this in a logical and systematic way. So some of the analysis categories that we've been looking at, we've been developing these based on perceptual results in the different experiments that we've done, but we're also trying to develop a kind of a taxonomy of analysis so that we can do this both with human analyzers, but also we're trying to develop algorithms where we could do this automatically based on XML scores, for example, for the symbolic layer. But as you'll see, there's some things that you can't do based on pure symbolic information out of the score. You need the sound as well. because a lot of these things depend on the way they're performed and the actual instruments that are used and the room acoustics, the recording techniques, and all these sort of things. So there's a signal part of this that is very important as well. So basically, the idea here is to have these grounded in perceptual theory, but then using them as tools for doing music analysis. So we have concurrent grouping, where things blend together or don't blend together, for example. Sequential grouping, where we have formation of auditory streams, one or more. We can have integration of some things into sort of a texture, where you can hear more than one thing is going on, but they don't necessarily segregate into separate streams. And then we can have stratification into orchestral layers and foreground and midground layers and things like that. We also have segmental grouping, as I mentioned, and I'll talk about a few different techniques here. One is antiphonal contrasts, and timbral echoes, and then timbral shifts, and then some general timbral contrasts that are not related to any of those, and then sectional boundaries. Okay, so I'll go through these in turn. So let's start off with concurrent grouping, blend and non-blend. Now, things that maintain certain structural relationships over time get grouped together and get separated from things that don't conform to those relationships. So a visual analogy of this notion is if you have a set of different dots there that start moving around, you can see suddenly that there's a form that emerges, and you recognize it as a kind of face-like thing, and the minute it stops, it's sort of fusing back into that whole texture there. So the idea here is there's certain relations that are maintained over time, and it's this movement together, this sort of common fate kind of motion in Gestalt principles that makes it sort of stand out from everything else, which is behaving differently. So it's the sort of behavior, the acoustic behavior of these things that we're going to be interested in auditory terms. So perceptual fusion results in the formation of auditory events. It's the basic idea of concurrent grouping. And for example, we have a number of different parameters that play a role in event formation, such as onset synchrony, harmonicity, and parallel changes in amplitude and frequency. Okay, not all these are always present, so for example, you can still have inharmonic sounds fusing together, but in general, the more of these principles that are operating at the same time, the more they tend to reinforce the formation of particular groups. And if they're not together, if things are asynchronous, inharmonic, and not parallel, they tend to get segregated into different events in a certain sense. So these three properties here, onset synchrony, harmonicity, and parallel motion and pitch and dynamics, for example, are used in a piece by Ravel called Bolero, where he stacks up all the instruments in a harmonic series and they all move and start and stop and things like that. So he intuitively understood that these principles were useful to create new timbres by fusing together multiple instruments and so on. Now these properties can only be gotten from, properties can be gotten from the score, but those are not all the things that are important, because fusion of multiple sound sources also depends on various kinds of spectral relations, such as do the frequency spectra overlap or not, and is the overall spectral density playing a role. So things that are very dense tend to form a single fused kind of situation, and things that are sparse and separated in spectra might not be heard as actually blending together in a certain sense. Okay. So important thing here is that the auditory attributes like pitch, timbre, etc. are computed from event properties, because grouping precedes the extraction of these, and so timbre depends on concurrent grouping processes. It's something that composers can actually create by getting different kinds of sounds to fuse together, which of course depends on how they get performed. Okay? Now musicians use the notion of blend, which we interpret as primarily related to the degree of perceptual fusion, but it's actually a bit more complicated in the musical use of the word. So, for example, an undergrad student at McGill, Pierre Jean-Ferrand, found that one can experience a sense of multiplicity and blend simultaneously under certain conditions. Okay, so this means that you don't necessarily have everything completely fused together in the musical notion of blend. You can sometimes have multiplicity, but it's the behavior of things that makes them all sort of fit together, to cohere together, even though you can tell there are multiple things. However, things that are strongly, that are completely segregated are not blended, and those that are strongly fused are strongly blended. So here's the basic grouping structure for concurrent grouping. In concurrent grouping, we distinguish blend from non-blend at one level. Then at the next level down, we have a couple types of blend. There's timbral augmentation, where a dominating instrument is augmented by one or more instruments, which may not be identifiable. There's timbral emergence, where the identities of the constituents are subsumed into the whole, for example. And then there's timbral heterogeneity, which we reserve for the case where you have synchrony, harmonicity, and parallel motion, but you still hear things as independent kinds of sound sources. Now these effects can either be sustained over time or can happen on a very short, brief kind of situation, okay, so where you don't have time to analyze things out. And for sustained events, they can either be stable in time in terms of instrumentation, or the instrumentation can be transforming over time. So let's see some examples of these. Here's one example from a piece by Debussy called La Mer, and this is the first movement. And here basically we have, it's a stable augmented blend, stable in the sense that it has constant instrumentation. And basically the English horn sound here is enriched by two solo cellos. So let's listen first to the English horn. Reinforced by two celli. And how those sound within the full context. Now some of the examples I'm going to play today are all done with the orchestral system developed by Denis Bouillon and Félix Baril, and what this allows us to do is to have a full orchestral texture, but then we can select out the different instrument tracks, which allows us to do experiments and things like that, also analyze the tracks independently in terms of the audio. Another example, here's a case of a multi-instrument blend in which harmonicity is not maintained strictly in order to respect the tonality, but the contours are the same and within a semitone or so, which coupled with the onset synchrony, tight harmonies and overlapping spectra reinforces the blend. So here. So here's a case where it's a little bit looser of a blend. You can hear there's multiple instruments, but they tend to cohere as a unit in a certain sense like this. Modeling this kind of thing requires relaxing the harmonicity constraint to a certain extent, which raises a certain number of problems, which Aurélien can talk about. Here's an example of a transforming blend in which the participating instruments evolve over time. So the violin timbre dominates here. This violin timbre is progressively enriched by high cello, clarinet, bassoon, and the English horn, and then two oboes which fall out in reverse order, creating a kind of a timbral arc that follows the melodic arc of the arc of the melody itself. of modeling, everything's unison and synchronous at this moment, but there's instruments coming in and out, which raises a certain number of issues for how do you determine that when you're adding something in, it's not something that's going to be heard independently, but it's actually going to fade into the general structure. So this poses a certain number of modeling issues as well that need to be developed. Here's an example of timbral heterogeneity or non-blend. Oftentimes we find these kinds of non-blends that involve inharmonic metal percussion instruments, for example. So they have a different kind of temporal envelope, but they also have the inharmonicity of their sound. So here's an English horn, first of all, enriched by a horn, or French horn, I guess, except it's actually German, French horn. And now we'll add in the glockenspiel, which is actually sounds 2 octaves higher than it's written here, so it's actually 3 octaves above the other instruments. And while it adds some sizzle to the sound, you can definitely hear it separately from all the other sounds in that particular case. So due to the spectral non-overlap, this has been explored by Sven Emil Lemke back in 2015, and also differences in the amplitude envelope as noted by Damien Tardieu and myself in 2012, and the harmonicity of these constituent sounds, these play a role in the non-blend of these different things. Now this one poses specific problems for symbolic modeling because it respects all of the ASA rules, okay, synchrony, harmonicity, parallelism, etc. However, it's the signal properties that keep it from actually playing a role. So we need to blend both the signal analyses and the symbolic analyses together to actually get the right answer on this one. Let's move now to sequential grouping. Auditory streams represent the behavior of sound sources over time. So if we have successive sounds from the same source tend to be more similar in timbre and pitch, and they tend to be more similar in loudness and more similar in spatial position and so on. So continuity and all these things help to connect different events together. And if you have discontinuities, then they tend to be fragmented or separated into different streams and so on. So one of the things here is that timbral differentiation can cause stream segregation, and timbral similarity can promote stream integration. So this is a way that composers can use timbre to actually create reinforced streams or segregate things on the basis of streams by creating timbral similarities or differences and so on. Paul Iverson and Calvin Bay and myself have shown that timbre-based stream segregation is directly related to timbral dissimilarity, so we can use timbre spaces to predict the probability of timbre-based stream segregation. Now notice in all of the blend examples that I presented previously, the sequences from integrated streams are either the instrumentation stays constant or evolves very slowly and smoothly. And we distinguish the notion of blending, which does depend on the maintenance of relations over time, from the process of connecting those events over time into auditory streams. Stream segregation is mostly the rule in a large majority of pop music where producers actually try to have you hear out all the different instruments that are playing. So here's our grouping hierarchy for that. So basically we have integration of sequences into streams or surface textures, which I'll talk about in a moment. And we can have segregation of auditory streams or orchestral layers. And as before, all of these can be either stable in instrumentation or transforming in terms of their instrumentation. Here's an example where we have, that's weird, okay. Here's an example from Schoenberg's 5 Pieces for Orchestra where we have a transforming stream integration involving a lot of different instruments. In this particular case, we have undulating timbral waves that are alternating between flute, clarinet, and bassoon, and then English horn, bassoon, and French horn and trumpet. On the other case, it creates a kind of a modulated timbre when performed appropriately. So if it's performed in a certain way, you actually hear this as a single stream with a kind of timbre that's modulating in time. If it's not done correctly, you hear this here comes in, that comes in, this comes in, that comes in, in which case you actually get some kind of fragmentation going on. Now we have another case here of stable stream segregation. So this is sort of like the one I showed previously with, first of all, the group of clarinets, one bassoon, and then the horns and trumpets, which are playing. And the other stream that's playing here is played with flutes and oboes and another bassoon. Together, you can actually hear these two independently, and of course there are differences in register and rhythm and so on, but those differences are being enhanced by the timbral differences of the blended streams. Here's another example of separate blended streams, again stable stream segregation. This is from Borodin in the steppes of Central Asia. And here in this particular part of the piece, he has two main themes that are going on, being played in different orchestrations. And here's a place where they actually both come together at the same time in counterpoint, and they have different instrumentations on the two streams that help segregate them. So we have the high flutes and violins separated from the, I can't see it very well there. Again, there are registral differences and rhythmic differences, but I want to make a point about register. People sometimes say it's not timbre, it's pitch, but believe me, there is no instrument that does not change timbre when you change registers on that. Timbre co-varies with pitch and dynamics in all of these instruments. So those things, while they might be playing a role as well, they also create timbral changes that are also enhancing some of these effects. Okay, so let's move on now to issues of higher level kinds of structures, sort of like textual integration. We call textual integration a case where it involves two or more instruments with contrasting but often interweaving rhythmic or melodic figures. They get integrated into a single textural layer, and they're perceived as more than a single instrument, but it becomes very difficult sometimes to actually track all the instruments, and so your attention is switching around, and it basically ends up trying to group things together into kind of a sort of a surface texture, which I call. Texture in the sense of tactile texture, not like things like homophony and polyphony and so on and so forth, as music theorists would talk about. The other issue here is stratification. So this is when we have two or more layers of musical material that are separated into more or less prominent strands and so on. And here we have the notion of foreground, middle ground, and background. I want to emphasize here the graded nature of the grouping in general, because you can have things that are more or less segregated or blended or stratified and so on and so forth, and it's the strength of these things that composers can play with to create certain kinds of musical effects. Here's an example from Smetana's De Moldau, from his larger work called Ma Vlast, My Country. And in this particular case, we've rearranged the score, so it's kind of interesting to see what's going on. On the top, we have two flutes and two clarinets that are playing a kind of a textural integration, which sounds like this. And then in the in another layer, there's strings, high strings that are playing kind of the main melody here, which they will become the foreground, alternating with the harp. And then in the background, we have horns and other strings playing kind of harmonic ground. I'll play the full context so you can see if you can track the different layers that are going on here. Foreground, middle ground, and background. Played the sort of the textural integration of flutes and clarinets. You can hear out the flutes and clarinets a little bit when they're played by themselves, but then those get sort of glommed together when they're actually in the full orchestral texture and really become a texture at that point. So this is a very interesting idea also to notice that the foreground is not necessarily the most active one. So the violins are the ones that are carrying the foreground, but they're playing high, so it's the height there, whereas the most active one is actually the middle ground in this particular case. So let's move on to segmental grouping. Okay, here we have a number of different kinds of things that we want to look at a little bit. Basically, any kind of acoustic continuity, discontinuity can provoke segmentation, including timbral discontinuity. And Irene de Liège has shown that this timbre can cause segmentation at a local level, setting off materials like motifs and cells and things like that. But she's also shown in other work that large-scale sections of music can be formed on the basis of similarities in register, texture, and instrumentation, therefore including timbre, for example. Therefore, timbre change can create boundaries, and timbral similarity creates a chunking of things into a kind of similar scenes that are set off from each other at those particular boundaries where change does occur of some kind. Again, I want to emphasize the play between continuity and discontinuity and its effect on boundary strength and fragmentation, because composers sometimes they don't want to have everything be completely segmented very strongly. You want small segments and larger segments and things like that. And so by playing with boundary strength and the degree of acoustic discontinuity, you can play with these kinds of things. So let's move into the examples here. Now here's our segmental grouping hierarchy. So we basically have timbral contrasts of various kinds, which I mentioned previously, and we'll go through some examples of those. And then we also have timbral progression, the one we've looked at, which is orchestral gestures, which I won't talk about today for lack of time. Let's move now to an example of segmental grouping of an antiphonal contrast. So here we have a call and response pattern with the call played by the flute, oboe, and viola, and it's responded to in the violins. And this goes back and forth. This is from Haydn's Military Symphony. So again, there's some registral differences, but it's the timbre that also is helping to set apart these different things. Note, however, in this example here, and so sometimes music theorists would say, yeah, but a true call and response is like they're sort of butted up, they're concatenated with each other. This is actually a case where Haydn was actually having these things allied with one another a little bit. So the first note of one is the last note of the other, and so on and so forth. Here's another example. This time it's a timbral echo, and this comes from Sibelius' Second Symphony. Rimsky-Korsakov writes often of the notion of timbral echoes in his orchestration treatise. And the basic idea is that the echoing instrument should somehow evoke a greater distance from the listener than the original instrument. And generally, distance is signaled by the direct reverberant ratio, but also by a filtering of higher frequencies as they get absorbed by the air or surrounding things in the environment and so on, and also by a lesser loudness. So the idea here is that one of these, the distance reverberation thing, can actually be played with if you have like offstage instruments and things like that, but the other ones can be played by actually playing around with the timbre of the instrument and the dynamics of the instrument and so on and so forth. One of the cases that Rimsky-Korsakov does mention is using a flute to echo, for example, a trumpet, and that's exactly what this example is from Sibelius. The softer, rounder sound of the flute is echoing that of the brighter trumpet sound in this particular case. Here's an example of timbral shifts. Okay, this one is taken from Schubert's Ninth Symphony in the first movement. So basically here we have an example of musical pattern that is passed from instrument group to instrument group. So it goes from flute, oboe, clarinet, and horns to violins, to violas and celli, to contrabass, back to celli, and then back to contrabass again. Against a lot of other stuff that's going on in a kind of repetitive fashion. So it's basically the sort of the dotted quarter note, eighth note rhythm that's being put in fourth here. Sort of downward trajectory, both in pitch and in the kind of timbres of these things, and he uses that to sort of set off this pattern so it's not exactly the same every single time. Getting some variation, timbre variation going on there. Here's an example of the general contrast taken from Sibelius again. General timbre contrasts can be used to set off different musical materials with distinct orchestrations in order to highlight this contrast. And here, these are contrasts that don't fall into those other categories. So it's not a call-response pattern, it's not a timbral echo, it's not a shift, but it's various other kinds of things which we don't necessarily have categories for yet, but that could be evolving in the future. And here the local contrasts and instrumental groups are used to set off alternating musical materials. And the first group in green, which you'll see in a minute in green, remains fairly constant with strings and horns. And then there's a second group that changes over time. So this is one that's actually evolving over time as well. See, there's a kind of evolution of the materials that are going here, but he keeps using this back and forth, this changing timbres, and then highlighting even stronger with the woodwinds at that one particular point there. Modulating concatenated contrasts involves simply detecting changes in instrumentation. However, as you can see from this particular Sibelius example, they're getting more and more lighted over time, which poses a certain number of problems for actually trying to model these kinds of things. That's why I think it would be interesting to try to sort out some of those things with these overlapping entries and exits and so on. Now, larger scale changes can be used to contrast sections, as in this Haydn piece presented in an orchestration graph format developed by Emily Dolan at Harvard, and she just moved to Brown University in Rhode Island. Note that in this case, basically, you've got in greens, you've got the strings, in purples and blues, you've got the woodwinds, in reds and oranges, you've got the brass, and then in the blacks and browns, you've got percussion. So basically you can see that there are sort of strong changes that are happening at various points as it's changing between these different instrument groups. So in this case, we're going to listen to a part where it's just where that horizontal bar bracket is there. I'm just going to play that particular part. So we have something basically playing in the winds and the horn, and then an orchestral tutti, and then back to winds and strings, and then again to an orchestral tutti. So you can hear these sort of sectional boundaries that are created. Here is that the fine-grained instrumentation varies somewhat from measure to measure and needs to be contextualized by longer stretches, suggesting that the time window of analysis is going to be crucial in segmenting such structures in terms of large-scale structures. So, what can we do with timbre music? We've shown that we can create new timbral percepts in fused events. We can enhance differentiation of auditory streams using instrumentation. We can form different orchestral strata and textures with different timbres and so on. And we can use timbral continuity and change to create a hierarchical structure of sections in music. So basically, if we put the whole thing together, we basically have sort of local event formation at the bottom level here. Then we have event sequencing happening at the next level up. And then the formation of larger scale units, a nesting of hierarchical units there. And the important thing here is it's not a sort of a unidirectional kind of thing. A lot of these feed back into one another in terms of the way they actually operate psychologically. So this means that we need to, when we're trying to model these things, taking into account that the nature of that higher level structures can be affecting our processing of lower level structures and so on. And I want to thank my colleagues at Play Music Library, which made this research possible, and also our funding partners and the ACTOR project. Thank you very much.
We have time for questions. Thank you so much for your talk. Thank you
222.
There we go.
Thank you so much for talk, Steve. Only a slight, I'm sure you thought about this in the example that you presented in general grouping, this idea of alternation or an acceleration of alteration, because your diagram is awesome. Not this one, yes, that one. Right, so yeah, if we can bring up the coloured screen, I mean, you're sort of demonstrating an alternation between approaches, and I'm just wondering if there was some sort of idea of acceleration of alteration, or or deceleration of alteration. So in other words,
oh yeah, he's definitely doing that here. I mean, you can see they get shorter and shorter and more overlapping,
yeah.
And so he's creating the whole texture of the alternation is actually creating a kind of forward drive in the piece there.
Yeah. So in some sense, it's almost like an acceleration of form.
Yeah, exactly.
So that, I guess that's also a question of how timbre and form are interrelated here, and whether whether you're making a distinction. Is it a terminological question of are you talking about form or are you talking about timbre? Right.
Well, I think the orchestration form is playing a role here, and there's times that, for example, the composer John Ray at McGill University oftentimes talks about. Sometimes there's a conflict between sort of musical form based on standard things like pitch and harmony and rhythm and meter and things like that, and orchestration form, because you can have them happening in situations where they're actually conflicting with one another and Mozart even is already doing some little things like this, for example. So they're both contributing to form, and what the global form is, I mean, that's where the bottom level that I was talking about, where we start talking about sort of a psychological foundation for orchestration theory, that's where we start taking the results of these things. And here you're talking about a larger scale effect, which is this acceleration and the formal aspects that are being created as a sort of emergent property of the things that are happening over time. So I totally agree with you on that.
Thanks. So I appreciate the artistic deconstruction of all the important compositional ways in which these fusions happen. And I was wondering if you looked at the performance aspects of how this gets affected, in terms of like how if two trumpets are trying to blend versus differentiate, how that intention affects the blend, or something I think a lot about is the timing and alignment if you're trying to get these two things together. I don't know if you have any thoughts on that.
Yeah, I think that's, there's a million variables to we can actually do that. We have planned to do some experiments because we can play around with these fine level details in OrgSim, so that we could adjust things like timing and tuning and things like that and see how they play a role as well. The other thing that's important there is also recording technique, and we're working with, we have two tone meisters involved in the Actor project. One is Martha DeFrancisco at McGill University, and she talks a lot about how things like mic placement and balance and things like that, you actually can create blends with it. And it's shown, for example, that if you have everything close mic, it's very hard to get blend. You need further miking where you start to get some room reverb that actually helps things blend together. So halls play a role, how things actually get performed in terms of timing and tuning and things like that. These all play a role, and we haven't actually gotten to the point of actually starting to do experiments on that, but I agree with you, they do play a very strong role. And some of the effects are going to be more susceptible to performance nuances than others. So I think things like segmentation, basically you're changing the instrumentation, and unless you're like really messing things up in terms of the dynamics and things like that, it's probably not going to change things that much. Whereas blends are very, very much dependent on how things get performed. If you take Bolero, for example, I've listened to about 20 different recordings of Bolero, and some of them, I think actually Ravel made a serious strategic error when he wrote the score, because the instrument playing the fundamental frequency, basically, he writes solo. And what do soloists do? Well, they try to make themselves heard, and so they're doing all kinds of things with timing and tuning and dynamics and things like that to make themselves heard. Whereas if it's really going to work, that person has to actually be fusing with all the other people that are playing the harmonics above that person. So and it depends on the different ones. Some of them you can hear all the instruments, and for me the really successful ones are where they all blend together and you can't hear any of the instruments anymore. And the Boulez one is pretty good, for example, with the BBC Orchestra. That works very well.
Thank you for bringing all these artistic details more to the forefront of scientific research. Appreciate it.
So you suggested considering these effects when modeling, and I was wondering if you could elaborate on what kind of models you're referring to.
I would suggest we wait till Aurelien's talk, or he's going to talk about that with Blend in particular. Because he knows more about it than I do.
I have maybe a historical question. To what extent have composers that have experimented with these blends and sort of been the pioneers, to what extent do they draw from intuition versus scientific literature, and did these developments just occur independently, or is there some evidence for crosstalk prior to the kind of work that your team is doing, for example?
I think the first people who started talking about it scientifically would probably already be in the late Romantic period with Helmholtz and so on and so forth. I mean, Berlioz wrote the first orchestration treatise, and that was already sort of mid-late 19th century.
And in that treatise, is there evidence of drawing from the scientific literature?
No, it's basically describing phenomena
right.
that people are hearing. And although he started talking about things like blends and so on, they're already doing it in Beethoven and Haydn and Mozart and Bach even, for example. So I think that must have been sort of pure intuition. At least I haven't seen any evidence of that. But we might talk about this with Julia Courcelle, who's actually looked at some of these issues, the linking between scientific work and artistic work in the realm of acoustics.
So we'll take one last question before break.
Sorry to dominate the question here, but you've given mostly orchestral, and I appreciate this was your main research area, but you did make a fascinating comment about pop music aiming to try and sort of, as I say, each individual voice being separated as a segmentation process. And I just wondered, if I could ask you to speak to other genres of music. I'm thinking in pop where you've got, say, the Beach Boys, and there was a lot of work done there about, blend and fusion sound,
with choir kinds of things that are going on.
Exactly. Yeah, and doubling organ with, all the keyboards and things like that.
Yeah.
So perhaps I guess my question is the degree to which some of your ideas here are applicable in other sort of more popular music, alternative or electroacoustic music or something like this.
Well, I think these apply to all musics basically, and because we use these. Basically, we're piggybacking in music listening on the top of a whole set of mechanisms that allow us to sort out the sound world, which is what auditory scene analysis is about. So we just take that into the concert hall, and performers and composers start to play around with those things and trying to create trompe-l'oreille effects where you could trick the ear into thinking that, for example, multiple instruments are a single instrument. Or with electroacoustics, you can do things like Roger Reynolds did when he first started hearing about this work of taking a resynthesis of an oboe sound, and then you split the even and the odd harmonics and send them to different speakers, and suddenly now you've got something that's clarinet-like and something that's soprano-like. So you can take sounds and split them apart with electroacoustics. One of the tricky things is if you start applying these analysis techniques, which we've done on about 85 symphonic movements, basically to this point, but from, let's say, Haydn up to Vaughan Williams, once you start getting into the later 20th and 21st century, it gets a lot more complicated. We're actually finding we have to develop new categories of analysis to actually fit with what's going on. Though things get very textural in a certain sense, but then we need to sort of subdivide those textures into different kinds of things that are going on. So there's still a lot of work to be done, and I think these things also play a role in a lot of musics of different cultures as well. So I think they're all based on how we hear, and we'd be interested in people who want to work on the more ethnomusicological aspect as well, I think. Thanks.
All right. Thank you for your flexibility, Stephen, zooming in, zooming out. This is our break point. Let's all thank Stephen for this wonderful first keynote. So we're going to